In this video we're going to look at making random patterns. This is built on a grid, a rectangular grid. You see all these circles are differently sized, which can be changed by pulling this slider here. So we're going to build this up. And I'm using now circles because they are good representations of other things you can build. You can set this largest size and lowest size, but you can of course also use your own object in the same setup. So if I, for example, show this here, 0, and I put in for example a hexagon there and take it in and spread it all over the place and use the randomized controls to scale it, it becomes something like this, and this is applied to your hexagon as well. You can also do a rotation on this afterwards if you want to make them rotate just as randomly. So how is this now built really? Here is what I attached now, but we can unplug that to avoid confusion. I pull that away. So this is for the circles, right? So first we have a rectangular grid, and I have a kind of a special setup here actually. It's because I want to have a specific resolution. I'll explain that later. That means the extents of the grid is always constant. Yeah, then we extract the points. We measure how many they are. And why do we do that? Well, we want to create random numbers here with this component. Exactly as many random numbers as is their placeholders. Well, by that I mean the points themselves. So if we hover here, we see that it's 1,681 placeholders for the circles in this case. As soon as I change something in the grid, this will change as well. So those placeholders goes to a circle, which is fed with random radii that goes in here, and the random radii is set up here. Then afterwards, what I do actually, I take out circles that are too small to be produced. So imagine you have a laser cutter, or maybe you have a CNC machine. They cannot possibly cut something that turns into 0.9 millimeters or something like this. It could be too small, right? So there's also a component here for culling, for removing such small circles. And then we add this. So we draw something in a curve, move it to the points here, and we then also extract the center of all our components and scale them. So this is what I showed now. And this is with the same equal sizes, and this is with the random values pumped into it. We can also swap actually between hexagonal grids and triagonal grids. So the hexagonal grid would look something like this. And then you can of course adjust also the highest, the largest, the largest and the smallest one already here. So there's many parameters at the same time. And I can go in here and do a triangular instead, a completely different system. But then, of course, you have to adjust your edges, your extents, so that it fits to what you are working with. For example, I wouldn't have as many in the in the Y. So I go down like this and have a reference around it. Say you're working 100, 100. You have to measure that then, so that it fits. So let's begin doing this from scratch. So I open a new document, and this little hexagon I can take out. So we start with choosing a grid, which is on vector and grid, and I'll take a square one this time. You can actually take out all of these, and then afterwards you can swap between them. And if you remember, they're all on top of each other, and you also see a plane here, which is kind of weird, but it's because it already has a default plane built into the component, so that's visualized actually in Grasshopper. So that means if you set your own point here, you won't see that anymore. Nevertheless, it's not so important to us right now. So these two, I'm going to work with the square grid, and the hexagonal grid and triangular grid I'm going to hide, so I mark them and right click and preview off. Then what I need here is some inputs. So we hover everything, right? The 2D grid with square cells. Square cells is pre-given in this component because we only have one input for the size of the grid cells. That means X and Y direction is going to be the same, so it turns into a perfect square every time. And then we have the other inputs here, number of grid cells in base plane X direction. It's 5, and it's 5 in both X and Y directions. So we need to, of course, change that. So we go to parameters and go to sliders, and for the size of grid cells, we can probably have something like this. It fits, just turns a little bit smaller. And here we should have something much larger, right? So maybe 50. It should be an integer as well. And you, mind you, if you go to 0, everything will break. So minimum 1, because it's impossible to do less than 1 row in each direction, right? Otherwise it won't really generate anything. So if I put in 1 and 1, that clearly becomes obvious, because then I have 1 row in one direction and 1 in another, which means I have, when I hover here, 1 rectangle only. Then I start spreading it out like this, and now it turns into something else. And that's also why I'm doing integers. I mean, that is number of rows in each direction, based with no decimals, because you can't have 1.5 row in each direction. That's impossible. What you can do also here is to actually create a sort of resolution situation. So if you go into maths and divide this row with this row and put it in, you will see that the X direction now is actually constant. So what I did is I simply divide the number of rows in X direction with the grid cell size. What comes out then is not an integer actually. So in between there, oops, sorry, double click and type integer. Is actually to be found here on parameters and primitive and integer. That turns off all decimals. So that's much more safe. We can use that. That's good. Now we can actually copy this. Copy and replace the A input with the second one here. Like that. And why do I do this? Well, maybe I want to have a very constant situation. I want to just change the resolution and not the extents of the pattern. You saw before how the whole thing scales when I don't do this. So if I want to have, for example, 2020, I go down to 13 here. And then I can pull, and it still changes, of course. But you have to measure the width, the outside widths, to see if that fits. So actually, if you want to measure this correctly, you should try to multiply these with the grid size. So if you multiply the grid size with the integer coming out here, you will see that it does change a little bit, of course, but it depends on, you have to limit the size of the grids, otherwise it turns into maybe not exactly what you want to have. So if I do that, for example, now it's almost 20, and if I pull down, you see it's stuck. It gets actually stuck by 20 somehow, quite close. If I go in here and edit and go down to decimals, for example, like that, then you see it's much clearer, and you can actually start getting very close to what you need. If you would need, for example, 20 times 20. And in both cases, of course, so if you have 20 there and 0.8, the auto measurements should be fine. And now, I mean, it's you can change the resolution and still have the extents of the whole pattern is still 20. Yes, so I can delete these if I want to, or have them there if I want to. You just have to check once in a while to see if this really fits. That's optional. What do we do next? Well, we want to use the points here in order to place something onto them. For example, circles. I'm gonna do a little bit less dense now, just to so it doesn't break down. My computer won't do that, but I strongly suggest that you do it, so you don't have too many points when you start doing this pattern. So if we go to curve and to primitive, we can do a circle first here. And where should we put the circles? Well, we should put them here on the point grids, of course. So if I simply use these are not visible, by the way. They are the corner points of all the the cells. They can be visualized by going to parameters and point, and we do this, and you see they are all on the corner points all over the place. So I'm using that symmetry or that geometries here to place my circles. The question is then what we do with the radius. The radius is constant for all of them. If I put something in here, I can definitely change the scale of all of the radius and then subsequently the size of all circles. But I need something more to make it random in this case. So if we go to sets and to sequence, we see a funny little figure here called random. It's actually, the icon is a cat in a box, which is probably a sense of humor from the developers. If I open it and hover, which I strongly suggest you always do with all components, at least if they're new to you, it says generate a list of pseudo-random numbers. And what comes out of that? Random numbers. And it also says a number already. You see there, 0.7711094. So where does that come from, really? And the answer is on the other side. So this is more or less like the question. We want to make a random list, and the answers are the inputs, right? So first of all, we need the lowest number and the highest number, and that's called a domain in this system. If you're familiar with other coding languages, maybe you recognize the way to write here, 0, 2, 1. It's a form of coding that communicates with the script which is inside this component. So actually, I can write something else. I can write, for example, with the panel, I can do that. I can go in here and write 0.523, for example, and I insert that into the R input, and then we have defined new lowest and highest number, and then I can look again here, and the number has changed actually. But it's only one number. That's kind of odd, isn't it? So if we hover on the N, we see that this is the number of random values that this component is generating, and on default it's only one number actually. So we could also go like this, and we can type 10. Mind you, never do enter like this on the panels. that means you're going to break the code and it doesn't understand what you want to say to it. So you have to keep it like this. You can make that a little bit smaller, and then I insert that instead. And then we have a completely different situation. We generated 10 numbers, random numbers, mind you, between 0.5 and 3, for example. You can, when I say for example, because we're going to delete this and do it in a more dynamic way in a minute. And the S input, that's the seed of random engine. So I can just visualize what's going on in a random engine here. So I do that. Now I see the whole list, right? And then I open a new slider and I type in maybe 100 here, even with an integer here. And then I put that in, and we see that we can go through the numbers very much and change them. So this is 100 different suggestions of random numbers between 0.5 and 3. So we need to do something else there, right? We have to attach this to the system somehow. So if we use this, we can use this already and just put it in actually. It turns into something quite weird. And why is this? It's because the list is built from rows here. So one row, second row, and so forth. So this is the easiest solution that Grasshopper can find currently for this pattern. That means that it takes the list. We can look at the list already on the points here. You see that it's nested into several lists. So the first list is called 000, and it has 21 points within it. And the next one is called 001. It's 21 points, and it goes on and on and on like this. This means that we're going to apply these radiuses only to the 10 first points, the 10 first rows. And that's why it looks so strange here. So it doesn't really fulfill its purpose. So we're applying this to, how many points do we have? If we hover here, we see we have 441 points. And this is only applied to 10 indexes, which means it's a little bit too little, right? But then again, if I would write now, how much was it? 441. 441. This happens. This is weird, of course. So we need to be sure that, you see this cable is dashed and this cable is not dashed, which is a problem, of course. So if we, for example, graphed this input to make them equal, grafting means to nest a list. No result either. If we perhaps flatten this output, then something happens, because then we have transformed this list into completely something else, namely one list containing all of the points. It's a complete different situation. And I also told it to have 441 different random values. So if I type 100 here, what happens then? This happens. This is the simplest solution that Grasshopper can calculate currently, which is, of course, not what we want. So I could type 441 because I measured that here, and you probably have some completely different number because it depends on this setting. But 441 will definitely change if I change my pattern, right? So we need to have a generic and constantly changeable adaptive number coming out of here. And that you can do with measuring the length of this list at all situations. So if you go to sets and you go to list and you go to list length here, measure the length of a list. So let's open that component and attach it to that, and then we hover. Let's see, 529 it says. So every time I change something here, I go up again there. Now it says 441 again, which means this is much better than to write like this. now we have integrated the resolution of the pattern into the random component, and you see everything works quite interestingly. Then again, we have a problem here because these are far too large, aren't they? We need to make that generic as well and dynamic. So if we go to maths and go to domain, we need to exactly find this situation. So how would you come about doing that? Well, if you hover, you will probably see this as domain of numeric range, and you will probably start searching for domain. And there's many of them coming up. And after a while, after a set of testing, you notice that this one is empty. You know, it's actually the same as doing a panel. So then we can open again here and do, for example, construct domain. This is actually two directions, isn't it? For a surface, it's an area domain, and here is a construct domain in one dimension from A to B. And if we hover on one of these components and look at what code comes out, 0 to 1 it says, that means it has the same kind of structure in the code as here, which is quite good and actually perfect for our purpose. So that means that we can use sliders instead of a panel and just put them in like this. And let's see what it says now. If I just pull a little bit on my slider here and hover 0.25 to 0.707. Yeah, well, that's pretty interesting. So that we can set there instead, and then the situation changes, and we can start generically, dynamically change the sizes of our random components here. Yeah, so what we see also, unfortunately, all the square grids, so you know that you can right click and take out the preview, and now you see the whole pattern going on there. And you can do the seeding engine there, and you don't need this panel anymore. This was just for showing something. Now we can do something more. We can namely do our own little shape here. So I go into center of inscribed polygon as number of sides 6. That was already 6. 0. I press 0 to insert it exactly here, and I go to curve on parameters, right click, set one curve, and I take that in, and now we're going to use the same system and the same numbers in order to scale all these components actually. So if we take move, double click and take move, which is to be found here on transform Euclidean space move. We move this component and use the points as a translation vector. So it's translating the vector from the 0 point to all of these points in the grid. Yes, and now we can actually scale this using the random seed engine. So scale, and we set this there. And where is the scaling center? That's the question. You see what happened here. Everything scaled to 0. It's because we need to hover again. So scale an object uniformly in all directions. Geometry to be scaled, base geometry. Central scaling is default 0, 0, 0. We need to find each and every center point here. We already have that, don't we? We have these. And now something completely different happens. So you see how these points are affecting the whole pattern. And we can then simply take the random engine and put that in, and let's see what happened there. Now it's quite much geometry on the screen, so it's perhaps better to simply hide this one, the move and the circle, and now we see that our hexagon has been scaled all over the place, and it's randomly scaled actually, like this. We can also do a rotation on this if we want to. So double click, rotate, and then we need to have the center of rotation. We hover again, rotate an object in a plane. Object to rotate, we have rotation angle in radians, mind you, so 360 degrees is 2 pi, 6.28. And then we have rotation plane, which is set to 0, 0, 0. That's why it's rotated like this. And on default, it's half a pi going around, so that's 90 degrees. So we need to set new rotation planes. And now they are rotating in place, as you can see here. But we also need random angles. So if we turn that off and start doing the seeding engine, you see how they are actually rotating and scaling in a quite wild manner. So this is a small setup, of course. What you then can do is you can, of course, copy the whole random setup and attach another one like this into the rotation device. So you have double. You have the double situation, so you don't have everything in one. But it turns into quite a mess, obviously. And of course, the point here is now attached to everything. So this is what happens when you sketch. So what you can do now to just simply swap between grids is that you go to parameters, go to points, and go to the point here, and then you start replacing all of these. And why I'm doing this, you will soon see. And list length here is actually the same for both, so we can skip that list length. So now what you're seeing now is actually where you start to optimize the pattern, the setup a little bit. So it's a lot of cables, I know, but it's how it is. Then we can simply take this grid instead and put it in there, and we'll see what happens. We don't have any settings yet. You have to build all these sliders into here, but still you can see that it's actually working already. You can swap between different symmetries, which is of course quite nice, like that. Or you can also just swap to the triangular pattern, but you should have these flattened, the output. I'm sorry, I forgot to tell you that. So that's a much better situation. All the patterns, all the grids flatten here for this particular setup. It's better. So now you see how you can swap between different symmetries. But we will stick to the square grid that we made from the very beginning, because there's something. Whoops! I wanted to hide the control points here. So you can go in and simply set the lowest and the highest. Another way to set lowest and highest pattern afterwards, which I also want to show you, is to go into the cull pattern. So if you go to sets and go to sequence and cull pattern, this, if I hover, removes elements in a list using a repeating bit mask. And what is that kind of a bit mask then? So list to cull. So anything that goes into here will continue I mean, this is our hexagon, right? And this hexagon is still being here. It's just a filter, it's still a hexagon. What comes out is 220 polyline curves. Before, they were 441. And you see here when I select it, and if I even hide the rotation, something weird is going on, right? And then you have to hover the P input and check. 4 locally defined values, false, false, true, true. That means that we have a situation that we can affect. So if we go into Boolean, set multiple Booleans here, and if I write, for example, false, false, true, the situation is going to be completely different. This means that you can manipulate true and false lists here in order to get yet another setup of patterns. But in this case, we want to measure how large these are and take out the ones that are too small. And generating true and false list you can do with maths and operators here. In this case, I would use larger than or smaller than. Sometimes I have to test myself to see which one it is, but I think larger than. So if we open larger than, you see that it measures if input A is larger than input B. And what comes out of it is true if A is larger than B. And here's another input saying true if A is larger or equal to B. So we don't really have to use that one. Or maybe you do. It depends. You can test and see what you like. So we could actually measure, for example, let's say we measure the area of all these, put that in and compare them to a slider. So if we go to area, measure the area here, put the area in, and we measured all the areas, and we also got center point all over the place, of course, so we can hide that because it's irritating to see it. And let's see how large they really are. They're really small, aren't they? So it's enough with a normal slider that I took from my Marco down here, which suggests things for me. Otherwise, my slider is above here on parameters and inputs. So now we have generated something. False, 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 true, 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 and so forth. This is a list that we could use for the color pattern. If I put it in, this is the situation we get. So, wow, we have to go back really much to exclude some of these. So let's say this is kind of scaleless, right? You have to go in and check what is the radius, what is that equal to a list, to a width, for example. You have to break down the area actually into a diameter to know exactly how wide this is now. But anyway, now we calculated with area. So something like 0.02, I would say is too small. And then I pulled it back to that, and all of those hexagons disappear. If I want something, if I say that the tolerance is a little bit higher, like this, no, lower, I mean, that the machine, for example, can handle something like this. This is all we get out from it. So it's also a good way of testing if your pattern is usable or not. Yes. So, thank you for watching, and I hope you can have fun with this.